All right, you guys, check it out. There are three main topics in calculus, okay? Limits, derivatives, and integrals. Everything is based off of those, right? So we just finished limits. We're starting our chapter on derivatives. Derivatives is like one of the foundations of calculus, okay? Here's how this works, you guys. All right, this is really confusing. This is a little bit messy. So I found something to show you. Let's see if I can get this up here. That one. Okay, there we go. Let's see here. All right, cool. There we go. Now, what a derivative is. A derivative is a slope of a tangent line to a curve. Okay? So actually, before I show you this, let's talk about a couple of words real quick. Let's go out here and say I've got, you want to start with a circle because you guys would have learned this in geometry, I think, all right? So here's a circle. This line is called a secant line, okay? It can go through any 2 points on the circle. This line is called a tangent line. I mean, it kind of has a relationship to the trig stuff, but it doesn't mean exactly that. This is a secant line. That's a tangent line, okay? And you would have learned that in like a geometry lesson or something about circles and stuff like that, okay? Same idea with a curve. Let's say I have like a graph like this, okay? If I draw a line with the slope between those 2 points, okay, that's a secant line. We don't do that much with secant lines, to be honest with you. And a curve, let's say I'm trying to find the slope of exactly right there, right? That's a tangent line. Well, it's really easy for me to find the slope of this line, you guys. Let's say this was like, you know, the 0.24 and this was like the 0.59. How do I find the slope? Well, slope is y2 minus y1 over x2 minus x1. And I can figure out that the slope of that line is 5/3. Easy. With a secant line, the slope is super easy. How do I find the slope of a tangent line? This is where calculus comes in. Spell it correctly, right? The entire definition of a derivative is based on finding the slope of that tangent line. Okay, why? Super important. We'll talk about it. All right. So let's go back to here real quick. Okay. So I have this point. And I can find the slope of this point and that fixed point. So like, let's say right there, you guys see the slope? It could, you know, I could calculate it. y2 minus y1, x2 minus x1. Okay. I could put that right there. Oh, that's got a 0 slope. I could put it like that. I could bring it over here, and I've got all these different slopes, okay? Now, what we're going to try to do is we're going to try to get an exact slope on that fixed point. So if we were to take that moving point and put it exactly right on top of the fixed point, okay? The problem is my line disappeared because it can't calculate a slope because it's the same point. You know what I mean? All right, so let's take that fixed point away a little bit. And I don't want to put it right on top of it, you guys, but I want to get it like really close. Hey, that's pretty close. But if I zoom in a little bit, it's not that close. So I'm going to be like, okay, let me get it really, oh, nope, too close. Really close. But that's not quite close enough. So I'm going to zoom in a bit, right? And I'm going to get this like really close without actually going on top of it. And I'm going to zoom in a bit, and I'm just going to keep getting this really, really close. Okay? Now, that's pretty dang close. Let's zoom back out. Does that almost look like a perfect tangent line that just touches it? Yeah, it's pretty close to a perfect tangent line. So the purpose of this is we take these 2 points and we get them so close together, like really close. In fact, I want the distance between them to be like 0.000000000, right? And in calculus, we know from our last chapter that we can do by using limits. Okay? Cool. Check it out. Let's look at this graph right here. Now, I'm going to actually do something a little different, I think. And I'm going to call this between here, instead of calling it delta x, I'm going to call it h, okay? So here's what's happening. I have this point right here. We're going to call this point 1. And point 1 is x is the x coordinate, and f of x is the y coordinate, okay? So that's my first point. And then I'm going to get another point. And I'm going to call this point x and a little bit. X and like a tiny bit. Now, they call it delta x because that's the change in x. Most things I've seen don't really call it delta x. They call it h. I'm kind of okay with you calling it either one, but h, like something really, really small. So as an example, let's say x, let's say we're super zoomed in, I don't know, is 2. And x plus h is like 2.00000001. That's the h part, right? That's the super, super teeny tiny part. Okay? And we go like this. So this point, x plus h, the y coordinate of that point is f of x plus h. Again, use an h or use a delta x, and that's fine. All right? Now, the way that we find the slope between 2 points, okay? So again, this point right here has an x coordinate. I'm going to make this a little bit smaller so you guys can see better. Okay? Has an x coordinate of x and a y coordinate of f of x. Okay? This point right here has an x coordinate of x plus a little bit. All right? Whether you want to use h or delta x or whatever. And f of x plus a little bit. Excuse me. Now, how do we find the slope of this line? Well, you guys know that slope is y2 minus y1 over x2 minus x1. You might have seen this as delta y over delta x, okay? Using these points right here, y2 minus y1 over x2 minus x1. But not just that. That is the slope of the secant line, okay? But then I want to take this secant line and I want to take this point right here and I want to move that point so stinking close, like really close. So what do I have to do to move that point so close? I have to make h really small. And you guys, really small is not 0, because 0 is 0. Really small is actually a limit as h gets really close to 0. That's bringing those points super far together. So check this out, okay? Now, whoa. What happened on the bottom here? Why did this change from x plus h minus x? Well, hang on here. X plus h minus x. Do you guys see that the x's cancel out? So it's just h. Or, like I said, delta x, okay? Like, down here it has an h in it, so that's fine. So the secant line is literally just a slope. The secant line is a y2 minus y1 over x2 minus x1. The tangent line is a slope as delta x, or h, gets infinitely small. That's bringing those 2 points, boom, right together. Perfectly, all right? That's called the derivative, okay? Notation really quickly. Here's some notation for you guys. All these things mean derivative. All these things mean derivative. This one, I read it as f prime of x. This, I usually call that y prime. The little dashy thing means prime. That means derivative. This is dy dx. This is a little bit of a fancy way to say it. That means derivative of y with respect to x. This is d dx of any function, the derivative of a function. Okay, these are all just different ways of saying derivative. And it's basically this limit as that change in x gets very, very, very small. This is the one that I like to use in particular with the h's. Okay, that's what I like to do. All right, really quickly, a vertical tangent line has no slope, so there's no derivative at a vertical tangent line. Okay, we're going to find derivatives. It's called differentiation. That's the verb form of saying we are going to differentiate this. We're going to find a derivative. All right? Okay, so check it out. Here's an equation. Guys, I know that this is tricky. Try to follow along with me, okay? This definition of derivative has a couple parts. It has f of x plus h, and it has f of x, and then it has h on the bottom, okay? So we got to find out what each of those things are as h goes to 0. Again, use delta x if you want. I'm going to use h. Okay. Quick review on f of something. Quick review, because this messes people up a lot. Okay, let's say f of x is x squared plus 1. What's f of 2? 2 squared plus 1, right? What's f of 9? 9 squared plus 1. What's f of q? We can still do that, right? It's, whoops, q squared plus 1. What's f of smiley face? It's smiley face squared plus 1. Doesn't matter. This is a function. It's saying whatever I input, I output that quantity squared plus 1. Okay, what's f of x plus 7? Well, that means I plug x plus 7 into there, squared plus 1. Okay? So that's like a little bit of a refresher on how we use f of x. Now, guys, what is f of x plus h? What that means is I plug x plus h in right there. This is the part, if you can get this down, you'll be fine. This is the part that is most difficult for people. X plus h squared plus 1. That's what that is. All right? So check it out. What is f of x plus h? Well, it's taking x plus h and it's putting it right in there. So you guys see that it's a little smaller. X plus h squared plus 2. Okay? Cool, cool. Come back here. What is f of x? Well, f of x is just x squared plus 2. And so here's my formula. I take f of x plus h that I found, right? I'll move that over there. Well, you guys can't do that, so that's kind of mean, but I won't move it. Here's what I'll do. I'll copy, paste it. Aha. Okay? Minus f of x. I'm going to copy, paste it. Now, you do have to be a tiny bit careful. Anybody see what the issue is here? When I'm subtracting something, I should probably keep that in parentheses because I'm subtracting the whole thing, over h. So it's f of x plus h minus f of x over h. Just like memorize that. Now, guys, that's the calculus. You're done. Everything from here on out is algebra stuff. Okay, so let's go back and see how many of you remember your algebra. First of all, I need to multiply that out, right? X plus h squared means x plus h times x plus h. And some of you might be able to do this in your head, or you could FOIL or whatever. You know what I like to do, especially when there's like all sorts of variables and stuff? X plus h, x plus h. Okay? When I multiply this, I get x squared plus xh plus xh plus h squared. And you guys, when I combine like terms right here, I get x squared, there's two xh's, and then there's an h squared. Okay? So look, I'm just rewriting everything. I'm not doing anything. I'm rewriting, but I'm changing this into what I just got. X squared plus 2xh plus h squared. That's that. Okay, what came next? Plus 2 minus that. Now, on the minus, just be careful. I do have to distribute that, okay? So minus x squared minus 2 over h. We're still doing algebra. I got to simplify this, you guys. Do you guys see what simplifies here? How about x squared minus x squared? plus 2 minus 2. Does that all simplify? All right. Now, we learned in our limits chapter, the test you guys just took, we learned that if you have a numerical limit, step 1 is plug it in. Okay? Now, when I plug this in, 2 times x times 0 plus 0 squared, I get 0 over 0. Oh, that's not good. That's actually not bad, but so we got 0 over 0, and you guys, we know that that means that there's a hole or something, but then how did we deal with that? We factored and we tried to cross off the 0 over 0, so let's do that. All right, right here, I could do a GCF, right? I could take an h out, and I'm left with 2x plus 1h over h, and then look, guys, that crosses out. And the thing I just crossed out was the 0 over 0. We've been doing this. So now I have 2x plus h. And then last but not least, the limit as h approaches 0 of this. Well, what's happening to h as h gets really, really, really small? Well, now I can plug it in. Because before it had a hole, and I'm getting really close to it, and I'm not touching it. So when I get rid of that hole, I can see that this is approaching 2x, because h goes to 0. And that is what the derivative of this is, 2x. The derivative of x squared plus 2 is 2x, okay? Now, over here, use your answer from part A to find the derivative at negative 3. Well, if the derivative of x is 2x, at negative 3, it's just going to be 2 times negative 3. And that's negative 6, okay? So that you have some understanding of what's going on here. X squared plus 2 is a parabola up 2. And what this is saying is that if I had a tangent line at negative 3, so it's like right here, a tangent line, that tangent line would have a slope of negative 6. That's what that's telling me, okay? So that's the derivative at that point, all right? Let's go through one more. We'll probably go through 2 more, but here we go. Okay, we need to find f of x plus h. We need to find f of x and h, and then we like put them all together, right? Okay, think about this as y and f of x are interchangeable, all right? Okay, so here we go. F of x plus h means I'm taking x plus h and I'm putting it in right here. So f of x plus h is the square root of x plus h, okay? Because again, this is f of x, and I'm just plugging in x plus h right there. So it's all inside the square root sign, okay? F of x, my original problem was square root of x, and then I have h, right? And when we put this all up, now do not forget, you're not allowed to forget this part, the limit as h goes to 0, very important. Without that, it's not a derivative, it's just a slope. Without that, it's like a secant line, it's not a tangent line, okay? All right, so I'm gonna go f of x plus h minus f of x over h. And with numerical limits, we know that the first thing we do is we try to plug in 0. Well, when I plug in 0 for h, you guys, look at what I get. I get square root x minus square root x over 0. I get 0 over 0. Wah, wah. Okay? But this is going to happen every time when you start off with this difference quotient. You're going to get 0 at the beginning. So we have to do something about this. Now remember, your steps on a numerical limit. Plug it in. If you get 0 over 0, we did factoring or conjugate. And conjugate comes if you have square root problems, basically, right? Get that out of the way. Okay, so here we go. Here's the conjugate, right? You guys remember this? Conjugate means opposite. So it's taking square root of x plus h minus square root x and putting square root of x plus h plus square root of x on the top and bottom. And I want to multiply this out. I do not want to multiply the bottom out, okay? I only want to multiply out the top. All right? You guys, you could do FOIL again, where we do like first, outside, inside, last. Again, that's a little bit tricky, so I'm going to do this box again when I multiply this out. Okay, square root of x plus h plus square root x, I'll put along the top. It doesn't matter which one you put where. Square root of x plus h minus square root x. Okay, look what happens. Let's just focus on this real quick. A square root times itself, that's just x plus h. A square root times another square root, well, let's just write square root x plus h. That's fine. A negative square root times that is a negative square root of x plus h. And then that times that. Okay, a negative times a positive is a negative. And square root x times square root x is x. Now, what you will notice happens is that and that cross off. And that's always true for conjugates. If one's positive and one's negative, those middle terms will cross out. So what I have left when I multiply this out is x plus h minus x. Okay? So this is going to turn into, that was just like algebra stuff. Let me rewrite this whole thing. Limit h approaches 0, x plus h minus x over h, and then all this. Square root x plus h plus square root x. Okay? Can I simplify this? Yeah, for sure. Those can cross off. So I have limit as h approaches 0, h over h, and then all this. Okay? Do you guys see what happens right here? The h's cancel out. So I have, and I have to just keep writing, limit as h approaches 0, 1 over square root of x plus h plus square root of x. And at the very end, h goes to 0. Square root of x plus 0 plus square root of x is 1 over 2 square root x. That is the derivative of square root x. It's 1 over 2 square root x. Okay, with all that. Woo! Crazy, crazy, right? Okay, we're going to just do one more. I don't think we're going to talk about alternate form. Well, maybe we will. Okay, we'll see how much time we have. Okay, so let's do one more here. This is with respect to t, so, I mean, that's weird, but whatever, I can still do this. Limit h approaches 0. It's just a t instead of an x. So I need to find f of x, t. See, I already messed up. F of t plus h, f of t, and h. And those are the three things I'm working with, okay? F of t plus h means I plug t plus h in right there. So you guys understand that that's 2 over t plus h. Okay? I plug that in. Give myself a little more room. F of t is 2 over t. And then h is itself, right? So it's f of x plus h minus f of x over h. And again, guys, of course, the first time I plug in 0, I'm going to get 0 over 0. That's what happens with these. 0, 0. So I get 2 over t minus 2 over t. I get 0 over 0. All right? Okay, I can't factor this. I can't conjugate this. It's not a square root. So what do I do with it? Again, from this point, algebra stuff. All right? Here's the algebra of this. Let's get a common denominator. You guys remember doing common denominators? It's like if this one's t plus h and this one has a t, okay, I have to multiply this on the top and bottom by t, and this on the top and bottom by t plus h. Okay? And then these have a common denominator. All right, so this is what I get. Okay, limit as h approaches 0. 2t over t plus h. I'm not going to multiply out that part. And then 2t plus 2h over t plus h. Okay? So I got my common denominator. And now that my denominator is the same, I can add the top parts. Okay, so my denominator was t parenthesis t plus h. All right, and on the top, I have 2t, I got to distribute that, right? Minus 2t minus 2h. Okay, and 2t minus 2t minus 2h. Do you guys see that those would cross off? Whew, fraction stuff for days. So here we go, limit as h goes to infinity. Okay, the fraction on top is this. The fraction on bottom is just an h. But in order to make it a fraction, I'm actually going to put h over 1. And so it's the limit as h approaches 0. And if I'm dividing by a fraction, you guys, I am multiplying by the reciprocal. So I'm multiplying by 1 over h. And finally, do you see what happens? H is crossed out. That's literally the step that we wait for every time. Okay, so this is negative 2 over t plus h. The last step, I can plug in 0. Once I cancel out that 0 over 0, okay? And so I get negative 2 over t times t plus 0, which is negative 2 over t squared. And that is the derivative of that. Negative 2 over t squared, okay? Woo, we're really getting into calculus here, guys. All right. Real quick now, I will show you alternate form. I got like 4 minutes before I try to keep these under 30. So I will show you the alternate form. And the alternate form is if I'm trying to find the derivative at a particular point, let's say I call that point, C, and then I call this point x, and this is f of x, and this is f of c. Again, my slope is going to be y2 minus y1 over x2 minus x1. So it's just a different alternate way of saying it. To find the derivative at 3, it'll be the limit as x approaches 3. So I'm bringing this point and this point super close to each other. I'm like grabbing this guy, right, and moving it until it's like right on top of that. So I'm moving the x really close to the 3. And the difference, instead of going f of x plus h, so it's this right here. So it's f of x minus f of 3 over x minus 3. Should not have that equals there, okay? F of x is that. F of 3, regular f of 3, well, that's 3 to the third. That's 27. Okay? Look at that. So this is just an alternate form. It's bringing the x to the number instead of x plus h and x. All right. When I go to plug it in, because anytime we have a numerical limit, we plug it in, I get 27 minus 27 over 3 minus 3. I get 0 over 0, which means I have to factor it. I don't know if you guys remember this, but we talked about it, I think on like one of the very first days of school. We talked about how to factor a difference of cubes. I'm pretty sure we did. It's a pattern. You just have to memorize it. If you don't have it memorized, I mean, it doesn't show up a ton. But basically, here's how you factor a difference of cubes. You go, okay, what to the third makes x to the third? X. What to the third makes 27? 3. And then you go like this. You square that. You square that. Multiply those together. I remember it because it makes a little smiley face. So you go square the x, that's x squared. Square the 3, that's 9. Multiply them together, that's 3x. And then the way your signs go, there's a little acronym you remember called SOAP. SOAP. SOAP stands for same, opposite, always positive. That negative, same, so that'll be negative. Opposite, always positive. It's just a way to factor cubes. If you don't know how to factor cubes, we just have to go back and relearn that, basically. Okay? But look what happens. Woo, woo. All right, so now I have the limit as x approaches 3 of x squared plus 3x plus 9, which I can now plug that in and get 3 squared plus 3 times 3 plus 9, which is 9 plus 9 plus 9, which is 27. And that is f prime of 3, the derivative at 3. Which means that if I were to graph this, the slope of the tangent line at 3 would be 27. Okay? So hopefully you guys are good. Took notes on that, and we we'll do some problems together in class on Thursday.